Hello everyone, I am Dr. Millie and you are watching MDAT classes, and today we are going to learn how to calculate packing efficiency of the crystal. Packing efficiency is a general term. We know that how efficiently that crystal is packed means more the number of atoms present inside the crystal, more will be efficiency of that crystal. But one thing we all know that packing efficiency will depend on that actually the crystal, the efficiency of the crystal will totally depend on the type of unit cells inside the crystal, because unit cell ही तो repeat कर रही है खुद को to make that huge crystal. So because unit cells are repeating themselves to make the huge crystal, the efficiency of unit cell we can find out, and accordingly the packing efficiency of the crystal will be taken out, isn't it? So first of all it will depend on what type of unit cell we are having in that crystal. Suppose if I am having this unit cell which is a simple cubic cell. अब अगर ये सिंपल क्यूबिक सेल है तो देयर एटम्स विल बी एट द कॉर्नर्स एंड कॉर्नर्स ओनली. If there are atoms on the corners only, there will be space at the center, and if there is space at the center, efficiency will be lesser. Okay. Agar I'm taking that another kind of cell, that is body centered cubic. In body centered cubic, the atoms are present at the corners as well as at the body center. So obviously more space will be occupied by the atoms, and we all know that simple cubic cell is having only one atom, BCC is having 2 atoms, and FCC is having 4 atoms. So depending on how many atoms are present inside the cell, unit cell, their efficiency will increase or decrease. But here we are finding out how much efficient they are. How much means we are going to find out, we are going to calculate the percentage efficiency, how much area, how much volume available is occupied by the atoms in that unit cell. So if this is a cell, complete cell, unit cell, इस unit cell का कितना area, कितना volume is occupied by the atoms, and how much is left out, how much is free area where the no atoms are present. More is the area occupied by the atoms, more efficient will be that unit cell. So how you going to calculate the packing efficiency? It can be calculated using the formula. I am writing down formula. Packing efficiency equals Z multiplied by volume of atom, which we are taking sphere, divided by total volume of unit cell, multiplied by 100, because we will be finding, we will be calculating only percentage efficiency of that crystal or that unit cell. So this formula you will be applying, where Z is indicating the total number of atoms in that unit cell. I am starting from simple cubic cell. Simple cubic cell. So if your cell is simple cubic, what will be the value of Z for it? 1, because there are atoms which are present at the corners only. So let's find out what will be the packing efficiency. The packing efficiency of the simple cubic cell will be, what will be the value of Z? 1. What will be the volume of atom, because we are considering it as a sphere? 4 by 3 pi r cube, divided by the total volume of the unit cell, and unit cell ka volume will be taken out by length, breadth and height of the unit cell, and that is A, because we are taking cube. Now multiplied by 100. So this way we can calculate the packing efficiency of the cubic crystal, simple cubic cell. Now can I use the relationship between A and R for the simple cubic cell so that I can simplify this formula? I am using it. We know that for the simple cube, we know this thing, if this is a simple cube and these are the 2 atoms present here, this is A, this is A now, so this is A for the simple cell, and if I divide it with the 2, we will get the R, isn't it? So A equals 2R here. We know this thing. For the simple cubic cell, the relation between A and R is this. So can't I use this formula here? So this is 4 by 3 pi r cube divided by A equals 2R. So 2R cube. Okay, so what it becomes? It becomes 4 by 3 pi r cube divided by 8 into r cube. Now this is out. What is left out? This only. So when you calculate these all things, I multiplied with 100, multiplied with 100. If you calculate all these things, you will get the answer as 52.4%. So what will be the efficiency of the simple cubic cell? The efficiency of simple cubic cell will be 52.4%. Same way, we can calculate the efficiency of the body-centered cubic. Body-centered cubic cell. And for that we know that value of Z is 2. How the value of Z is 2 for this? Because we know that one atom is present at the corners and one atom is present at the body center, and that is why its value of the Z is 2. So let's calculate the packing efficiency. The packing efficiency will be packing efficiency. कैसे निकालें? Now this time Z का value is 2 and sphere will be 4 by 3 pi r cube divided by a cube, and a का relation with the r for the body centered cubic we have to apply that also, that for the body centered cubic we know that a equals 4 by root 3 r, या r equals root 3 by 4 a. So we are going to convert this into this ना, a को r में convert कर रहे हैं, so we can use this formula here, 2 into 4 by 3 pi r cube, and a cube is converted into 4 by root 3 r cube. ठीक है, so this way if we calculate it, r cube तो r cube से चला ही जाएगा, so this is what cube multiplied by r cube is cancelled, whatever is left out. If you calculate all the things, you will get the answer as 68%. Now the next one is face centered cubic. So the next one is face centered cubic, and for the face centered cubic the value of Z is 4. Why it is 4? Because we know that the atoms are present at the corner, that will contribute 1 by 8 and the value will be 1. Next is there is atom which is present at each and every phase. There are 6 phases and the contribution of atoms present at the phases will be 1 by 2, and according to that it will get 3 atoms. So 3 plus 1 will be 4. So Z ka value is a 4 for the face centered cubic, and for that packing efficiency, how we can calculate? The packing efficiency can be calculated as Z multiplied by 4 by 3 pi r cube divided by a cube, but here a ka relationship with the r we have to utilize, and how this a and r related for the face centered cubic, that you have to remember always. Most of the students do mistakes here, so do remember that a equals 2 root 2 r, form FCC. So let's apply the formula. 4 into 4 by 3 pi r cube divided by a equals 2 root 2 r. So I am doing it here, 2 root 2 r cube. Are you getting this? So if you calculate this, you will get the answer as 74%. The efficiency of the crystal of face centered cubic unit cell which is having, that is showing the crystal will be having efficiency 74%. So I hope you are clear in this concept that packing efficiency means total volume में से कितना volume is occupied and how much is left out. तो कितना रह गया है वो तो we can easily calculate, क्योंकि if it is occupied इफ इट इज ऑक्यूपाइंग 52%, 52.4%, तो आप इसे माइनस कर दीजिए, 100 में से माइनस कीजिए, यू विल गेट द लेफ्ट आउट स्पेस देयर. एंड द नेक्स्ट थिंग इज सिंपल क्यूबिक सेल की एफिशिएंसी, इट इज लीस्ट एफिशिएंट क्योंकि द नंबर ऑफ एटम इज least. It is highest efficiency also of face centered cubic, that is 74%. I hope this video will be helpful for you to calculate it. If you like this video, please hit the like button, share it and subscribe my channel. Thank you very much.